Today's lesson is on inscribed angles, so let's just start with a definition. An angle whose vertex is on a circle and whose sides contain chords of the circle is an inscribed angle. So let's draw one. Got to have a circle if you want to have an inscribed angle. Vertex is on a circle, so the vertex, so this, let me get a different color. So this would be our vertex, and the sides contain chords of the circle. So here's a chord, here's a chord. So this angle right here, angle 1, is an inscribed angle. Let's draw another one. I could have a vertex here. I could have a chord here. I could have a chord here. That would be an inscribed angle, angle 2. So inscribed angle, if you got a vertex on the circle and the sides are chords of the circle, you got an inscribed angle. All right, what do we have next? An arc with endpoints on the sides of an inscribed angle and its other points in the interior of the angle is called an intercepted arc. So let me go back up here to this picture. So let's take our red inscribed angle. Here's our inscribed angle, and if we want the intercepted arc that's associated, it's the endpoints, an arc with the endpoints on the sides of an inscribed angle. So here they are. There's one endpoint. There's the other, the sides of an inscribed angle, and all the other points on the interior of the angle. So all these other points along here that are on the interior of angle 1, that's the intercepted arc. Okay, so now we got a theorem. The measure of an inscribed angle is half the measure of its intercepted arc. So in this picture here, angle ABC is my inscribed angle, and here's my intercepted arc. So I know that the measure of the angle is half the measure of the arc. So let's do an example. What are the values of A and B? Where is A? Oh, here's A. Here's A, arc PT. Arc PT measures A degrees. So what do we do? Let's look. If we look at this angle here, PQT, that's the inscribed angle that intercepts that arc, right? And so we know from the theorem up above, the measure of the angle is half the measure of the arc. So in this case, we know the angle is 60 degrees. Okay, so as I was saying, we know the measure of the angle is 60 degrees, so we know that's 1/2 the measure of PT. All right, so if we just multiply both sides by 2, we get 120 equals A. That's the measure of that arc. Okay, and we want to know what's the measure, or what is B. So let's look at B here and see if we can figure out what arc that angle B intercepts. Well, it intercepts A and then 30 degrees more. So I know that B is going to be 120. That's the measure of arc PT, which is A, plus 30. Therefore, B equals 1/2. I almost said 150, but B is 1/2 of 150. So that's 75. And the degrees is already on there. Okay, one more. Let's see what we got here. What are the measures of A, B? Okay, so all these angles. So let's start with A, and let's see what the measure of the arc is that A intercepts. Well, let's see. The measure of angle A is going to be 1/2 of the intercepted arc. The intercepted arc is 190, so that's going to be 95 degrees, right? The measure of angle B is going to be 1/2 of its intercepted arc, and B intercepts this arc, 64 plus 90, so I believe that's 154. So the measure of angle B is going to be 77 degrees. Why don't you pause here and find the other two and then come back and check. All right, did you get 85 for the measure of angle C and 103 for the measure of angle D? I hope so. If you didn't, put a star there and let me know in class and we'll figure out what went wrong. Okay, well, hello. I don't know how this guy ended up here again, but we already solved him. So the question is, what do you notice about the measures of the opposite angles? Well, let me rewrite them. The measure of angle A is 95 degrees, and its opposite angle is C. The measure of angle C was 85 degrees. The measure of angle B was 77 degrees, and its opposite angle, which is D, is 103 degrees. What do you notice? I notice that those opposite angles are supplementary. They're supplementary. That's right. And if you look here, that's the corollary 3 to the inscribed angle theorem. The opposite angles of a quadrilateral inscribed in a circle are supplementary. Okay, let's look at corollary 1 of that theorem. It says two inscribed angles that intercept the same arc are congruent. So if you look at angle A here, it intercepts this arc. If you look at angle B here, it intercepts the same arc. So since I know that those two angles intercept the same arc, I know that they got to be congruent. All right, corollary 2 says an angle inscribed in a semicircle is a right angle. So if I take a semicircle here, inscribe an angle, so put the vertex, it doesn't matter where I put the vertex, and then two chords, that's always going to be a right angle. So if I were to put the vertex over here, chord, chord, that would be a right angle. It's always going to be a right angle when you inscribe an angle in a semicircle. Okay, so I bet what we have left are just a bunch of practice problems. So let's see what we got here. What is the measure of each numbered angle? Well, look, I got 40 and 70 and my mind starts turning. What do I do? What do I do? But hey, angle 1, that's all they're asking me for, and it's inscribed in a semicircle, so I know the measure of angle 1 is 90 degrees. I don't have to worry about that 70 and 40 and all that other business. If I wanted to know what the measure of, let me call this angle here 2. Let me call this one 2. Guys, what's the measure of angle 2? Well, the measure of angle 2 is 1/2 of its intercepted arc, right? So the measure of angle 2 would be 20 degrees. I could make up all kinds of other problems, but hey, there are a bunch here on this paper for us, so let's do it. What is the measure of angle 2? Oh, let's see. Angle 2 intercepts this arc right here. If I call this angle 1, it intercepts the same arc, right? So I know that angle 2 is congruent to the other angle, so the measure of angle 2 is 38 degrees. And what's the measure of the intercepted arc? Twice that, 76, right? 76 degrees. Okay, that's how we do these problems. All right, let's see what we have here. 1, 2, 3, 4. What do you notice about 1 and 3? 1 and 3 are easy, right? Because they're inscribed angles in a semicircle. So the measure of angle 1 equals the measure of angle 3, which is 90 degrees. So what does that leave us for the measures of angles 1 and 2? Let me erase my lines that I have here. Sorry, not 1 and 2, 2 and 4. Let's see what we have here. Let's look at 4. If I take this inscribed angle, number 4, here's the arc it intercepts, and the measure of that arc is 140. So that means the measure of angle 4 has to be half of 140, which is 70 degrees. And what do we know about angle 2? We know it's supplementary to angle 4. So that means the measure of angle 2 is going to be 180 minus 70, which is 110 degrees. Oh, got another theorem here. 12, 12. the measure of an angle formed by a tangent and a chord is half the measure of the intercepted arc. So if you look here, here's a tangent, here's a chord. The measure of the angle would be half the measure of the intercepted arc. So for instance, if this arc measured, I don't know, let me say 100. If that arc measured 100, then the measure of angle BCD would be half that, or 50 degrees. That's all that theorem tells us. So let's do some more examples. SR is tangent to the circle at Q. If the measure of arc PMQ, I like to have colored pencils for this little unit so I can highlight my arcs. So if this is 212, what is the measure of angle PQR? Oh, so here's the angle I'm looking for, right? Here's the angle I'm looking for. So what I'm going to do is I'm going to say, well, I'll find the measure of angle PQS first, right? And I know it's going to be 1/2 of 212, which is going to be 106 degrees, right? And then I know it's a linear pair. PQS and PQR are a linear pair, so the measure of angle PQR is going to be 180 minus 106, which is going to be 74 degrees. All right, another thing I could have done is I could have said, okay, well, if the blue part of the circle is 212, then I know the entire circle is 360 degrees, so this part would be 360 minus 212, and then I could have taken half of that number to get the measure of angle PQR. Okay, how about this one? KJ, that's my dog's name. KJ is tangent to the circle at J. What are the values of X and Y? What are the values of X and Y? So let's see what we got here. So if this angle Q is 35 degrees, let's look at it this way. 35 degrees, then here's the intercepted arc, right? So I know that arc right there has to be 70 degrees. Now I got to erase that so I can see where X is in there. X. So if this arc right here is 70 degrees, then that little angle is half of that, right? So X has got to be half of 70, which is going to be 35. Okay. So that's how we get that one. And what do we need now? We need Y. Oh, look at this. Look at this. This little angle right here is inscribed in a semicircle, right? So that means this is 90. So Y is going to be 180 minus the sum of the other two. So 125. So Y is going to be 55. And it's already got the degrees, so we don't have to put that. Okay, so what you got left are about 6 practice problems. So as we always do, we're going to stop here and let you work those and come back and check your answers. All right, for our first practice problem, I've got inscribed angle A intercepting a 108 degree arc, which means the measure of A is half 108, 54. B, inscribed angle B intercepts a 60 degree arc. Therefore, that angle is half 60, which is 30. And then what I did to find C, I can see that angle C and this one that I labeled angle 1 here are vertical angles. So I just used the triangle angle sum theorem from this triangle to figure out what angle 1 measures. And I got 96, which means that's got to be the measure of angle C. If you got any problems, put a star on it so we can talk about it next time. Okay, in this problem, I can see that the 25 degree inscribed angle intercepts arc A, which means that arc has to measure 50. And then if I look carefully, I see that angles C and B not only intercept the same arc, which is a semicircle, which is 180 degrees, and half that is 90, but I got two angles inscribed in a semicircle, and I know that that will always be a right angle. So they're both 90 degrees. Okay, this one took a little bit more work, but I knew that this angle here is a right angle, so the first thing I wrote was this statement that A plus B is 90. And then I know that this arc right here is a semicircle, so 120 plus E has to be 180, therefore E has to be 60, and then that tells me what the measure of angle A is because it's half of 60, which is 30, and that tells me that B has to be 60 since A plus B was 90, and then I use the fact that I've got the other semicircle over here. I'll draw it in red. This semicircle, and I know part of it is 56, so the other part has to be 180 minus 56, which is 124, and therefore that angle has to be half of 124, which is 62. Okay, two more. This one I just pulled out the little triangle. I pulled out the little triangle and put it here so we could see that we need to do the Pythagorean theorem on it. How did I know that this side is 15? Oh, because I've got a diameter here that's perpendicular to a chord. Therefore, I know it bisects the chord and makes this side here 15. And then when I plug that into the Pythagorean theorem, I find out that the radius of that circle is 3 times the square root of 24. Kind of the same thing down here. I got to use the Pythagorean theorem on this little triangle. And what I know here is that this entire chord is x units long. I just need half of it, right? And how do I know that this piece right here is half? Well, because once again, I've got a diameter that's perpendicular to that chord. Therefore, I know it bisects the chord. So I called this little piece A. I used the Pythagorean theorem, and then when I figured out what A is, I knew I had to multiply that by 2 to get the entire length of this chord. All right, if you had any problems with those questions, look at them again, see if you can figure it out, and if not, we will go over them in class next time.